So where Farkhondeh also wanted to talk about sensitivity analysis and especially about the screening method for global sensitivity analysis. She did some earlier work on the use of what she called the dummy parameter to identify non-influential parameters within such a screening method. And maybe to set some things up, if you see this text on the screen, you will think, oh, I will need some glasses or maybe some sort of filter just to be able to read this text. Well, the same thing goes sometimes when you're performing screening as a sensitivity analysis. Because if you're performing screening, you also require some sort of a filter. Because in theory, when you have a screening method, you would say, okay, the non-influential parameters can be screened out and they actually go with a sensitivity index equal to 0. But actually, due to numerical approximations, we very often see that those non-influential parameters do have some small sensitivity index. So it's not completely 0, and it's hard to identify those non-influential parameters. So this is mainly due to the fact that a sample is still just a sample. It's not everything, and there might be some noise to the output, and it's hard to detect those non-influential parameters. So how can we decide if a parameter is non-influential or not? Well, a way to do that is what we did is by saying, okay, we will set a threshold for this deciding this non-influential or influential parameters. And therefore we say that a threshold for parameter screening is necessary to identify non-influential parameters. So where does that come from? Well, recently now it's not so recently anymore, it's 2017, we were looking at those different types of sensitivity analysis. And there we introduced the sensitivity index, the sensitivity index of the dummy parameter to serve as such a threshold to identify influential and non-influential parameters. And that's what I'm going to try to show today, how this actually works and why we can actually prove that this is correct when performing a screening analysis. I will do this in 3 steps. The first one being, I will shortly explain the 2 global sensitivity analysis methods where we applied this dummy parameter. Then we will talk a little bit more about the dummy parameter. And then finally, I will show you that it actually works. So the first method is a Sobel method. It's not a screening method, but also there we try to apply the dummy parameter. And yeah, it did work somehow. I will show you. So the Sobel method in general is very known. It's a variance-based method. You have a sample matrix and a resample matrix where you start from. And the second method that we used is the pawn method, which is more or less a screening method. It's not completely screening, but some people say it is. And there this is a density-based method, which is moment independent. And the actual value of the pawn method depends on the distance between 2 cumulative distribution functions, where we then can use the Kolmogorov-Smirnov statistic to see how far they are apart from each other and how important the parameter is. And we applied those 2 global sensitivity analysis methods to a SWOT model, which is a semi-distributed hydrological model, which can also be used for water quality. But for water quality, we used a conceptual water quality model, which was at that time when we first gave the presentation, still under development. But now this has been finished already. And actually that's what we wanted somehow to present now. Now for the dummy parameter, if we go into that more deeply, yeah, we don't want to have the dummy parameter to have any influence on the model output. So it's just an additional parameter which can vary, but there is no influence on the model output. For example, if this would be your model, ax squared plus bx plus c, you could introduce a parameter d, which has no influence on the output. So you can vary d, but actually it should not add anything to the model. So we don't actually add it explicitly to the model equations when we do our research, but we just keep it in the sensitivity analysis algorithm. So if we look at the number of factors that we will be using within the sensitivity analysis, this is the number of model parameters plus 1. But what does this mean also for the model equations or the model evaluations? If we look at the model evaluations, somehow it depends on which method we are using, either the Sobel method or the Pawn method or any other method. The number of model evaluations is depending on that one, but the additional model evaluation is very, very limited actually. For example, for Pawn, let me explain Pawn a little bit. Like I said before, we have the difference between the conditional, the cumulative distribution functions. In blue here, so the full line is the conditional one, the red dashed line is the unconditional one. So the red dashed line is the one where we start from. It's without changing any model parameters. And then we change a certain model parameter and we get the conditional one. And then like I said before, the distance between them, the Kolmogorov-Smirnov statistic can be calculated, and that gives you how influential that parameter is, because if it's more, if there is a higher distance, then the parameter, of course, is more influential. In theory, what we would know is that if there is no influence at all of a certain parameter, we would see that those two would be the same. So actually, both would be unconditional. So it's not a conditional one and an unconditional one, but since there is no influence, it's unconditional. Now, what we see, however, is that when we do this with a parameter which is normally non-influential, we sometimes see some difference, because even if you take two different sample sets, you can still have some difference between those CDFs. So the only thing in this case, what we needed to do to test the use of the dummy parameter was to generate an additional unconditional cumulative distribution function. And we did this for 10,000 model evaluations, which resulted in 200, no, it's not resulting in 261,000 model evaluations. It's just the other method that requires 261 model evaluations, but can get into that deeper later on. Now for Sobel, this is a little bit different. Like I said, we have a sample and a resample matrix. For example, this could be the sample matrix where we have 3 parameters, and in this case, 4 different samples. Let's call this X. A second resample matrix for the same 3 parameters, so 1, 2, 3, let's call it, or in this case, A, B, C, and D, E, F are the same parameters, so A corresponds with D, and the resample matrix is totally independent of the sample matrix, and we call it X prime. Now in Sobel, what we do to calculate the influence of a parameter is we combine the different those 2 different matrices, and we see that, for example, in this case, there is parameter 1 from the first matrix and parameter 2 and 3 from the second matrix. And in this way, we can see the influence of one parameter on the model output. Similarly, we can do it for the other parameters, and in that way, we get the value, actually the calculation of this variance with respect to the influence of a certain model parameter. Now, within this equation, and now we're getting a little bit into the equations itself, there is this part where we actually take one, so this XRI that you see within this ellipse is actually the one that comes from the first matrix. So for example, the one where you point at, it's this one column of this specific subsample matrix. And if we want to go to this dummy combination matrix based on this, we can actually see that as a parameter D in this case, or let's call it, yeah, D from dummy, let's call it, is not influential. It's not contained within the sample matrix. So your resample matrix, so a combination of the initial matrix and the second matrix, would be actually just X prime. So that means that this variance is also the variance of X prime. And this means that there is no additional model evaluation required. And the good thing is that we actually were able to prove that this threshold method really works. And I will show you that in just a second, because if you look at the results of either at the left-hand side, the Pond sensitivity index, and the Sobel sensitivity index at the right-hand side, there is a certain amount of parameters that seem to have some sort of influence. But if you look at the, if you look at it, it's hard to say where does it really end, where is this influence and where is this threshold necessary, and that's where this dummy matrix dummy parameter really can help, because if we add here the dummy parameter to our simulations and the same results as before, but just this dummy parameter is added, then we can really put this threshold for every parameter that has a certain influence. If it has the same influence as the dummy parameter, we say that it's non-influential. And in that way, we can actually say that, all of those parameters that are having a sensitivity index that is higher can be seen as influential, and all the others can be regarded as being non-influential. So maybe an additional example. Also here we have this dummy parameter, and again we can cut off. This was the initial result for the water quality model, and again we could cut off there due to the dummy parameter between the non-influential and the influential parameters. I'm going to skip this because that's something, you could also see from this actually that this RK2, which was visible in the previous slide, and this one, that it is very influential. If you would look at the posterior distributions of the parameters, if we were optimizing, that is RK2, which was the most influential one, is also the one that is best identified by the algorithm, which also shows that this is the most influential parameter. So that brings us to the end of this presentation, but there is actually one thing remaining now, and we can conclude that the dummy parameter is actually easy to implement. It requires almost no additional resources, and it can provide you a measure for the accuracy of your numerical approximation. And the good thing is that its sensitivity index can serve as a practical threshold to identify the non-influential parameters. So we can say that this dummy parameter provides the filter that we need to adequately perform parameter screening. So there is one more thing left here, and that's this text from the start of the presentation, which you were probably not able to read, but luckily I showed you that there are some filters, and luckily I do have a filter here available, which is actually just saying that this is an awesome conference. And with that, I close this presentation, and I give the floor to the convener again.
Thank you very much, Jiri, for this nice presentation. Very much inspiring and providing new tools for model application and so on in sensitivity analysis fields. Is there any question? We have 1 minute for a very quick question.
Yeah, Jiri, I like this idea. It's clever. I'm wondering about the sensitivity of the dummy variable to like how it's distribution you give to it and like its coefficient of variance, and whether there would be variability if you put in 5 dummy variables? Do you get the same result every time, or do you describe different influential parameters?
Well, we didn't try to introduce more than one dummy parameter, but I would expect that actually they would behave in the same way. The problem is that if you do introduce additional ones, then of course you need additional simulations and model evaluations. In this case, for example, for Sobel, there were no additional simulations required, so that was a good thing. And then for Pond, for example, also the additional number was not too high compared to the total amount. But of course, if you would add more and more, then yeah, your calculation should be adapted, and that might yeah, that might bring some. Now, in general, I would say that it's actually, yeah, not always the good thing to add more. I would more suggest to have more simulations then, so more samples, because that could also reduce the variability and the how should I call it, the numerical approximation. If you just say, okay, I can add more, then add more simulations in general, I would say.